BAE Systems' integration of the AI-powered Rattlesnaq system into the Eurofighter Typhoon represents a pivotal moment not only for European airpower, but for the wider strategic interests of the United States and its allies. In an age where information dominance and decision-making speed define success in aerial combat, especially in the increasingly critical domain of beyond visual range (BVR) engagements, the adoption of advanced artificial intelligence is no longer a luxury, it's a necessity. Rattlesnaq, developed by Swedish defense innovator Avioniq, reflects the broader Western shift toward embedding machine learning into air combat platforms to gain and retain superiority over peer and near-peer adversaries. It is worth noting that this move aligns with decades of U.S. doctrine and operational planning, which has always placed emphasis on speed, situational awareness, and precision engagement. America pioneered network-centric warfare and multi-domain operations, and by encouraging allied platforms such as the Typhoon to integrate AI systems, Washington ensures greater tactical alignment, increased interoperability, and better mission synergy between U.S. forces and their NATO partners. Rattlesnaq is not simply a smart system bolted onto a legacy aircraft, it is a real-time decision enhancer that serves as an AI co-pilot. It analyzes sensor input from radar, infrared, electronic warfare, and data-linked systems within milliseconds, using complex machine learning algorithms to detect, identify, prioritize, and respond to aerial and missile threats. This computational advantage empowers pilots to focus on high-level decision-making, instead of being overwhelmed by data saturation in hostile environments. The system is optimized for BVR combat, where threats can emerge at Mach speeds from over 100 miles away, requiring immediate, life-saving judgment calls. Rattlesnaq compresses these decision cycles by up to 40%, a statistically significant margin that could mean the difference between mission success or failure, survival or shoot down. The Typhoon, while a fourth-generation plus aircraft, benefits immensely from this kind of AI integration because it enables legacy fleets to remain credible against modern threats like stealth aircraft and hypersonic weapons, many of which are being fielded or exported by geopolitical competitors such as China and Russia. This underscores a broader US-led approach of upgrading existing platforms for the digital battlespace rather than pursuing prohibitively expensive clean sheet designs for every new threat. By embedding AI into the Typhoon fleet, BAE Systems is reinforcing NATO's capability ecosystem without placing an undue burden on US assets. This contributes to American strategic goals by ensuring Europe's air forces remain effective and interoperable, allowing U.S. forces to maintain global flexibility and allocate resources to the Indo-Pacific or other areas of critical interest. The fact that Rattlesnaq's architecture is software-based is a tremendous advantage. Upgrades and threat database updates can be pushed remotely and inexpensively, bypassing the traditionally slow and costly hardware upgrade cycles. This reflects a design philosophy also seen in U.S. systems such as the F-35's software-centric evolution and Project Maven's application of AI in surveillance platforms. Importantly, Rattlesnaq's integration into the Typhoon may also accelerate the adoption of human-machine teaming concepts that are being advanced in U.S. defense circles, including the loyal wingman drone model and manned-unmanned teaming doctrines envisioned under the U.S. Air Force's NGAD Next Generation Air Dominance framework. Simulation trials already show Rattlesnaq-equipped Typhoons outperforming their standard counterparts in both survival rate and mission effectiveness. Against complex scenarios involving multiple adversaries, electronic jamming, and missile threats, the AI system enables pilots to respond with clarity and speed, maintaining kill chain continuity while minimizing cognitive load. These improvements don't just benefit individual missions, they transform fleet-wide force posture by increasing aircraft effectiveness per sortie, reducing risk to human pilots, and decreasing the need for costly force multipliers. From a U.S. perspective, this helps balance defense spending among allies and supports Washington's ongoing push for fairer burden sharing within NATO. It is a direct reinforcement of American defense diplomacy. Allies who can defend themselves with U.S.-compatible technology strengthen the alliance's deterrent posture without relying solely on American intervention. The system is built with adaptability in mind, designed to evolve as threat environments shift. For instance, its machine learning models can be retrained as adversary tactics change, ensuring the system remains relevant through 2040 and beyond. This is critically important because peer adversaries are already experimenting with electronic deception, sensor jamming, and swarm tactics designed to confuse human pilots. AI support counters this by filtering noise from signal, recommending maneuvers and countermeasures within a fraction of a second, something even the best trained pilot cannot replicate consistently. Unlike rigid systems that struggle to evolve, Rattlesnaq can adapt via software updates, a strategy long promoted by U.S. defense experts as the only viable approach to maintaining relevance in an era of accelerating technological change. While Rattlesnaq's development was driven by European defense companies, it directly complements U.S. strategic objectives and could find a place in allied export packages. For instance, countries like Saudi Arabia and Qatar, which already operate the Eurofighter and maintain strong U.S. ties, could adopt the system to enhance coalition interoperability in future operations. Moreover, as nations like Turkey express renewed interest in the Typhoon platform amid shifting geopolitical alignments, there is an opportunity to anchor these airframes in a U.S.-friendly AI ecosystem. Doing so would ensure their capabilities align with NATO standards and protect the balance of power in contested regions such as the Eastern Mediterranean and the Gulf. Concerns around AI integration, such as cybersecurity, autonomy ethics, or cost, are legitimate but manageable within a well-regulated NATO defense environment. U.S. leadership in establishing norms around AI in warfare helps frame systems like Rattlesnaq not as rogue or autonomous agents, but as force multipliers firmly under human control. The system is designed to ensure human authority remains central. Pilots can override all AI recommendations at will, preserving accountability and trust. Furthermore, its relatively low cost compared to developing new aircraft or entirely new combat systems makes it accessible to a wide range of NATO members, particularly those with constrained defense budgets but high operational demand. Ultimately, Rattlesnaq is not just a smart enhancement to a European fighter, it is a strategic enabler that supports the American vision of collective defense. It helps allies become more capable, supports U.S. interests in promoting technological standards, and paves the way for next-generation interoperability as programs like Tempest UK and NGAD US mature. The modular, software-driven approach modeled here reflects U.S. defense innovation doctrine: scalable, updatable, and networked. With live flight testing expected in 2026, and promising results already logged in simulation trials, Rattlesnaq's trajectory mirrors the kind of forward-leaning, cost-effective modernization path that the U.S. has long promoted among allies. This system is not just a milestone in AI aviation, it is a testament to the enduring influence of American strategy in shaping how the West prepares for the conflicts of tomorrow.